All right, this is Honors Algebra 2 Pre-Calculus. We are doing section 5.8 in Algebra 2, which is solving quadratic inequalities, and this is our second video. So sometimes your sign charts can be tricky because of repeat factors, but it's important that all factors, even ones that repeat, appear on your sign chart. Sometimes you can also logic through the solution based on your understanding of square numbers and their relationship to negatives. Specifically, for real numbers, stuff squared is non-negative. And so we're going to go over some of those tricky problems now. Let's just grab a pen real quick. All right, cool. So going over some of those tricky problems. All right, so here we have x squared minus 2x plus 1. So there's a couple different ways to do this. The first thing that we're going to notice is that this is asking us when this function is negative or 0, right? That's the thing we're being asked. So you always want to identify the thing you're being asked. So when you factor x squared minus 2x plus 1, right? So x squared minus 2x plus 1 is going to factor into x minus 1 times x minus 1, or x minus 1 quantity squared. So there's a shortcut to this particular trick problem if you see it. This is a square, which means that it is positive or 0, right? And this is asking you, when is it negative or 0? Well, the only time that that's going to be true is at the moment when it equals 0, because positive is not the same as negative. So the only time that a positive or 0 is less than or equal to 0 is at the moment when x minus 1 is 0, which would be at x equals 1. So it turns out that what you're going to get is a graph that looks like this. It's a smile that equals 0 at 1 and goes back up, right? Well, since you're asked when is this thing negative or 0, the answer is that at x equals 1 is the only time that this thing is either negative or 0. Now, that's one way to do it. The other way to do it is to notice in this equation that you end up getting the same answer twice, that you get x equals 1 as your what's called a double root, right? It happens twice. So on your sign chart, the only number that's going to go on there is 1, but your factor needs to show up twice because it's a product of this factor twice. So if you do this times this, you're going to get a negative, then a 0, then a positive, and then a negative, and then a 0, then a positive, right? The same factor twice. So what's going to happen is your x squared minus 2x plus 1 is going to net positive all the time except at 1 where it's 0. So your only answer to when is this thing negative or 0 is at x equals 1. So my answer is literally just x equals 1. It's not an interval. All right, so same thing here. You can give it a try, right? So this is asking me when is this function positive, right? That's when it's asking when is this function strictly greater than 0, which is when it's positive. So if we want to know when this thing is equal to 0, there's a couple options. One shortcut is to notice that this factors into an x plus 3 times an x plus 3 or an x plus 3 quantity squared. Well, if you're asking when this thing, which is either positive or 0, is positive, it's pretty much positive all the time except when it's equal to 0. The only time this thing won't be positive is when x plus 3 equals 0. So it's not positive when x plus 3 equals 0, which is going to be at x equals negative 3. So my answer is going to be every point that's not negative 3. So negative infinity to negative 3, skip over negative 3, and 3 to infinity. So if you don't see that shortcut option, right, the other way to do it is to look at the equation, right, and we get that this is an x plus 3 times an x plus 3 equals 0, which means that we get that the only 0 is at negative 3, which is a double root. It happens twice, right? So if you were to make the classic sign chart, oh, and the other way to spot this is that you're looking at a graph that looks like this, sorry. There's negative 3, so it's going to end up being up here and up here pretty much everywhere except at negative 3, which is what we get here. If you do it with the sign chart, right, x plus 3 is going to have to show up twice on there, right? Here's your negative 3 and your negative infinity and your infinity. So these are both lines with positive slope. In fact, they're the exact same line, so they're going to look like this, which means that my x squared plus 9 plus 6x plus 9 is going to be positive, 0, and positive. Since I want the windows where it is strictly positive, again, I get the same set of answers. All right. So this is a case where I give you one that doesn't factor because it's good for us to see what happens when things get more difficult. So this doesn't factor. You could try and factor all day. The only way you're going to factor a 5 is with a 1 and a 5, and they definitely don't add up to a 3x. So this is asking me, so the ask here is where is this function positive, right? Because that's what greater than 0 is. So unfortunately, when I go to find my equation, it doesn't factor, and I'm going to have to use the quadratic formula. So x squared plus 3x plus 5 equals 0. Well, it's prime. It doesn't factor, so I'm going to get negative b plus or minus the square root of b squared, right? So b squared minus 4 times a times c all over a 2 times 1. Well, what I want you to notice is that this inside is a 9 minus a 20, which is a negative 11. So that's non-real. Okay, so what that means is there are no real roots. Okay, so this thing doesn't intersect the x-axis at all, which means it's either always above the x-axis or always below. Well, since this is a smile, right? Since this is a smile, what we have is a smile that is going upwards and is always above. The reason I know it's above is because it never hits the x-axis, and if it were a smile below, it would have to hit the x-axis. So this is always positive. Always positive. So my answer is going to be negative infinity to infinity, right? Again, a smile below the x-axis, right? If this is my x-axis, a smile below my x-axis would intersect because it goes up forever. So let's go ahead and try a P6. Same idea. This is another one that's not going to factor. So this is asking me, when is this function 0 or positive, right? That's what greater than or equal to 0 means. So that's what I'm being asked. So I noticed that when I look at the equation, it does not factor, right? Negative x squared plus 5x minus 11. So I go ahead and use the quadratic formula, and I'm going to get negative b plus or minus the square root of b squared is going to be a 25 minus a 4 times an a, which is a negative 1 times a c, which is a negative 11, all over a 2 times a negative 1. Well, again, this inside is going to end up being a 25 minus a 44, which is negative. So there are no real roots. What that means is that we're not intersecting the x-axis at all. This is a frown, so it must look like this. It's a frown below the x-axis, right? So if we're asked when it's 0 or positive, the answer is never, right? The answer is never. There is no solution that makes this true. Okay, so this thing is literally always negative. We were asked when it's 0 or positive, so there is no solution. All right, so in E7, we're going to go ahead and do one that is not quadratic. We're going to take it a step up. So I'm going to factor, so I want to find when this is, so the question I'm being asked is when this function is positive, right? That's what I'm being asked because greater than 0 means when is this function positive. So I'm going to look at the equation, which is x cubed minus x equals 0. And I'm going to factor out an x and be left with x squared minus 1, which is a difference of squares. So I'm going to end up with 3 factors equal to 0. So my 3 zeros are x is 0, x is negative 1, and x is 1. So now that we're stepping up into things that are not quadratic, I'm again going to advocate that you really want to make the fancy sign chart, not just the picture sign chart, right? Now, you can make it as a picture, and I'll walk you through how in a sec. So negative 1 is the first, numerically the first 0, then 1, right? My factors are x plus 1, and x minus 1, right? And the product, which we know is an x cubed minus x, is going to be the result of these things. Okay, so all 3 of these are lines with positive slopes. They all look like this, right? They all look like this. So x is 0 at 0, which means it's negative before it hits that 0 and positive after. X plus 1 is 0 at negative 1, so negative before it's 0 and positive after. And x minus 1 is 0 at 1, negative before it's 0 and positive after. So I get a negative, because 3 negatives will give me a negative, positive, negative, and positive with zeros here. So since I was asked when is this thing positive, strictly positive, my answer would be these two intervals, which would be -1 to 0, and again from 1 to infinity, right? That's my answer. Now, the other way to do this is if you remember what a positive cubic looks like, right? So a positive x cubed goes like this. A negative x cubed goes like this. So the other way to do this, if you know this, right? So if you know this, the other way to do it is to recognize that you have a positive x cubed here and that the zeros are at -1, 0, and 1. So your graph has to look like this, right? So since you know it's this kind of x cubed, and if you did that, you're going to get the same two answers. You're going to get this window and this window, which is what we got there. All right. Cool. Let's do a P7. So I'm going to go ahead and take out, so I'm going to notice that I want when this function is positive, right? That's what greater than 0 means. So you want to figure out what they're asking. Then I'm going to go ahead and look at the equation to find the zeros. So I'm going to take out a -5x and be left with an x squared minus 4, which is a difference of squares. So I'm going to get -5x, x plus 2, x minus 2. So I'm going to get that either x is 0, or x is -2, or x is 2. So again, you can do this one of two ways. If you remember that a negative cubic, right, so a negative x cubed looks like this, you could use that information to draw this really quickly. Here's -2 and 0 and 2. It crosses, crosses again, crosses again. Since you want when this thing is positive, you can see that it's this window and this window. So if you do it this way, you can get that your answer is -∞ to -2, parentheses, and 0 to 2 again with parentheses, and that's fine. The other option, again, that involves this knowledge. If you have that knowledge, it's great. If you don't have that knowledge, you have other options. So if I choose to make the more traditional sign chart, right, my factors are -5x, x plus 2, and x minus 2. -5x is a line with a negative slope, which means it goes backwards. So at 0 at 0, it's going to be above the axis, cross 0, and then be below the axis. The other two are lines with positive slopes. So x plus 2 is 0 at -2. So negative and then switches to positive. X minus 2 is 0 at 2, negative, and then switches to positive, which means that my result, my -5x cubed plus 20x, is going to be positive, because there are two negatives, negative, positive, and negative, right? And so then the answer I want is this interval and this interval, which is the answer I already got. All right. Okay, so E8, same idea, just a little bit longer. So again, the question here is when is this function positive, right? Because it says strictly greater than 0. So that's the thing I'm being asked. So, oh, my bad. All right, so that's the thing I'm being asked. So now I'm going to go ahead and take a look at that equation. I want when -8x to the 4th plus 24x cubed minus 16x squared is 0. I'm going to take out a GCF of a -8x squared, and I'm going to be left with an x squared minus 3x plus 2, which means that this is going to factor into an x minus 1x minus 2. So my zeros are x equals 0, right? Which is actually going to turn out to be a double root. We're going to talk about that in a sec, but it's because it's x times x, right? X minus 1 is 0, which would be x is 1, or x equals 2, right? So again, if you know what a quartic looks like, if you know what an x to the 4th looks like, you can do this visually, but I'm going to argue, an x to the 4th with a negative in front is going to look like this. It's going to look like an m, right? So if you know that, right, if this is knowledge that you have about a negative x to the 4th, then you could totally lean on that information and recognize that you have a 0 and a 1 and a 2. Double roots, you kiss but don't cross the axis. So what's happening is we're coming up, we're touching at 0 but not crossing, right? And then coming down, up, down, right? And we cross at those 2 points. And if you see that, that's great, right? But you're not always going to be able to see that, and I think that's pretty tricky, and I'm going to argue that this is one of those times when it's really useful to use the more complicated sign chart. So the more traditional sign chart is a little bit easier. So a negative 8x squared is going to be 0 at 0, but negative the rest of the time, because this is a graph that looks like this, right? It's a parabola that touches at 0, but then frowns the rest of the time. My x minus 1 is going to be 0 at 1, and because it's a line with a positive slope, it's negative before it crosses the axis, and then it's positive. Same thing with my x minus 2, but it's going to cross at 2, right? So that's what that looks like. So that means that my net result is going to be negative, negative again, positive, and then negative. And that's going to jive with what we saw in my rather complicated graph up there, right? So this is, I'm just going to say function. So I want when this thing is positive, and it's going to turn out that this is my only answer, right? And you can see that that's true in both cases. So my answer is going to end up being 1 to 2. All right. Again, knowing this information and knowing the kiss but don't cross thing about the x being a double root at 0, that's useful. And if you know it, it makes it a lot faster. But again, you're not always going to know all of that information. All right. All right, so we're going to go ahead and do a P8 that is similar to E8. Again, these are harder than your textbook actually has because obviously your textbook's talking about quadratics, and this is a quartic. It's got an x to the 4th. So first thing, this is asking me, so we want to know the ask, right? The ask is when is this function 0 or positive, right? Or positive or 0, right? That's the ask here. You want to know what the ask is, right? So that you know what question you're answering. So if I look at the equation, right? My equation is going to be 3x to the 4th plus 21x cubed plus 36x squared equals 0. I want to find the zeros. There is a GCF of a 3x squared. What's left is an x squared plus 7x plus 12. So I have 3x squared, x plus 3, x plus 4. And you can double check that that's right. When I set these equal to 0, I'm going to get x equals 0, but because of that x squared, this is going to be a double root, and that's going to be relevant in case we're going to be drawing stuff later. If you choose the graphing method, that's going to be helpful. I'm also going to get x is negative 3 and x is negative 4. So if you're going the graphing route, an x to the 4th with a positive looks like a w of some kind, right? It doesn't always look like a nice perfect w, but that's kind of the gist of it, right? So if you're choosing to do it that way, remember that you kiss but don't cross the axis at 0. So here's my negative 4, my negative 3, and my 0. If you're going the visual route, this is going to be a w. So it starts up. It's going to cross the axis at negative 4. It's going to cross the axis again at negative 3, but then it's going to touch and not cross the axis at 0, right? So that's what makes it special for being a double root. So cross, cross, kiss, but don't cross. So since we're asked when this thing is positive or 0, my answer is going to be here, here, and here, and include all the zeros. So if you do it this way, and again, it's great if you can do it this way, but not everybody chooses to have that knowledge. It's going to be from negative infinity to negative 4 with a bracket, and from negative 3 up to infinity, because the only weird thing in the middle would be that 0, and if this didn't say equal to, you wouldn't be allowed to include the 0, but it does say equal to, so you're allowed. So that's my answer. If you don't see it that way, that's fine, right? One of the things that we've talked about a lot in this class is that as you move forward in math now, you're doing things selfishly, right? So you learn some of the stuff you learn to make your own personal life easier. If you know what this graph looks like because it's a 3x to the 4th, and that makes your life easier, that's not cheating. That's just awesome. If you choose not to know what it looks like, then you need another option for how to solve this. And I really don't care what you pick. You just need to make sure that you can solve this when you don't have a calculator. So I'm just going to call this function because it's too much. I'm not going to deal with it. So a 3x squared is going to be positive everywhere except at 0. And you can see that if you picture what a 3x squared looks like. An x plus 3 is a line with a positive slope, so it's going to be negative before it crosses that 0 and positive after. The same will be true of the x plus 4. So I end up with a positive, negative, positive, and positive again, and that jives with what we already saw, which is that I want these intervals, and I'm allowed to include the endpoints because I'm allowed to equal 0. Cool. So that is the end of our P8, and I think our next, so this is a challenge, and then we're going to go ahead and, I didn't do an E and a P, I just wanted you to try this one. So this is already factored, right? So already factored. So you can figure out, the first thing you're being asked is, so the ask here is when is this crazy looking function positive, right? That's what you're being asked. When is the function positive? So when you want to figure this out, right, you first need to look at the equation and figure out when this thing has zeros. So if you're able to just do that in your head at this point, like if you're not stressed at all about just looking at it and being able to figure out the roots of something that's factored, that's awesome. The answer is going to be at 0, which I want to point out is an even root because it's squared, right? At x equals 2, which is also an even root because it's to the 4th, right? At x equals -3/2, which is an odd root because it happens 3 times, right? An odd root. And at x equals -7, which is also an odd root. Again, that's not because these are even numbers. It's because of this is an even number and this is an even number, right? So what makes it an even root is that these are even powers. Here's the reason that's relevant. The even root is going to net non-negative, right? And the other even root is going to net non-negative, all right? But these guys both behave as though there's only one of them. So when you make your sign chart in this case, right, what you need to recognize is that the x squared, so we put my stuff on my sign chart, right, my negative infinity, my -7, -3/2, and 0 and 2 and infinity, right? And again, this is totally meant to be a challenge. I have my x squared. I have the x minus 2 to the 4th. Both of these are going to net positive except at the moment when they are 0, right? They're going to net positive because of that even power, right? Because when you put something to an even power, it can't come out negative. So they're both netting positive. And then this 2x plus 3 to the 3rd, I think it's a 3rd, maybe it's a 5th, 3rd. It's going to behave as though there's only one of them. It's going to behave as the 2x plus 3 does, because if you cube a negative, it's still negative. If you cube a positive, it's still positive. So it's going to behave just like the line would have behaved. And similarly, the x plus 7 to the 5th is going to behave just like x plus 7 would behave, because if you put something to the 5th that's negative, it stays negative. If you put something to the 5th that's positive, it stays positive. So what's going to happen is that your function is going to be positive, negative, positive, still positive, and still positive. So if you're asked when this function is positive or just positive, the answer is here, here, and here, and here, but you can't include the spots where it's 0. So your answer, right, your answer is going to be -infinity to -7, parentheses, and -3/2 to 0, skipping over 0, 0 to 2, skipping over 2, 2 to infinity. And that is our challenge problem.